Video. Okay. All right. Okay. Well, good morning, and again, I appreciate your flexibility and your patience. And so, I have posted a syllabus, and it is now available in the modules. And I guess your first homework assignment or homework zero is to just kind of read the syllabus and sign off on this academic integrity agreement. Um, and it basically just says you're going to do your own kind of work on your own. I've also posted the first homework assignment, which is available here, and you will download these files and you will knit the RMD file into a PDF. And so, the very first time you do work with this, it can present a challenge. And so don't hesitate to come visit me during office hours. You can share your screen on Zoom and we can try to troubleshoot any kind of problems that you might be facing. Also, your TA is going to be a good resource to help you get everything up and running as well. But yes, I have office hours and don't hesitate to try things out and hopefully we can get everybody kind of squared away and running up and running, and so you have that. Okay, I also have I posted some video guides. These videos are a couple years old, but I think they're still good. I mean, maybe the websites look a tiny bit different, but the idea of still kind of downloading and installing R and all of that should still be working. Okay. But let me know if any of my videos are severely outdated and I need to um, redo or re-record them for them to kind of work. Okay. So with that, let's go ahead and take a look at our first lecture here. And I want to just get started with some concepts of data visualization. So as far as data science goes, one of your most powerful tools available is going to be to visualize your data. And what that means is just being able to kind of take the data that you have and present it in a graphic manner, okay? In a way for us to be able to understand and interpret the data that way. That's going to be kind of our most powerful and also kind of the first tools that we should learn. And so the package I'm going to use is something called ggplot. Okay, ggplot is a bit of software that we use with R and RStudio. And um, in the next few slides, you're going to see a whole bunch of kind of computer code and things like that. Okay. And I fully recognize that for many of you, you have no experience with R whatsoever. I fully recognize that. And so when you see all of this code and whatnot, it can feel very overwhelming, right? You see a wall of code, it feels like you're staring at hieroglyphics or something like that. And I'm going to be saying like, oh, all of this makes sense and everything. And I'm going to say it's easy, but in the beginning, it's going to feel like a lot. Okay. But just like anything else in life, like learning an instrument or playing a sport or something, reading and writing code is going to take time and practice and patience. Okay. And you wouldn't expect to just pick up a guitar and become immediately proficient. And so, don't worry if all of the code that we see on these next few slides don't all make sense. Okay. You will get better at reading. And then, come back to this lecture later, and use it as a reference. And eventually, it will start to make sense. Okay. And, and within a few lectures and a few weeks, you will feel comfortable telling the computer what to do with the code and things like that. It's just the way we interact with the computer and the way give instructions to the computer is via code. And uh, for now, you just have to kind of trust me that telling the computer to do things via code in the long run is more efficient And then, using a touchscreen interface or clicking things, with an app or something like that, because it's going to be specific and you will get the same results every single time. Whereas, every time you kind of click and things, things could change around and you can end up getting slightly different results. Um, so anyway, this is just to kind of give you a heads up and a warning. Again, if it might feel like a lot in the beginning, but that's okay. We're gonna just kind of jump in and I will try to kind of hold your hand as we go along. Right now, I'm not expecting anybody to be proficient, but I will be exposing you to a kind of a lot of this code. And as we go on, I'll be explaining each of these different things. Okay. A lot of the stuff is going to be coming from this kind of book called the R Graphics Cookbook, which you can read for free in your browser at rgraphics.org. Also, our textbook, Modern Data Science with R, Chapter 3, also does a good job of introducing ggplot. Okay, so ggplot, and formally the package name is called ggplot2, is created by Hadley Wickham, central part of a set of packages known as the tidyverse. And the GG stands for Grammar of Graphics, kind of this conceptual idea or system created by Wilkinson. And it gives a kind of a formal and structured perspective on what data graphics are and what they try to achieve. Okay. Um, you know, there's R comes with its own kind of base graphics and native abilities for creating graphs. But I'm a big fan of ggplot, and this is the method I'm going to be recommending, and we'll be taking a look at it. Okay. Um, kind of the central idea of a data graphic, okay, is that we are mapping properties of the data to visual properties of the graphic. Okay, that is the central idea of data visualization. We are mapping properties of the data to properties of the graphic. Okay, so imagine we're going to create something called a scatter plot, where I'm going to take values, okay, in our data, and we are going to plot them. Okay, and we have visual properties like where horizontally a dot is going to go, the X position, or where vertically it goes, the Y position. Um, we have other things like the color of the point, the symbol of the point, all of that. And if the graphic doesn't take properties of the data and put them into visual properties, it is not a data visualization. It's just a graphic. But here we want to have a data graphic. So this is just a fake data set, and it's very kind of a simple thing. I have 6 rows and I have 4 columns, and this represents, just imagine six imaginary people, and I have their height in inches, their weight in pounds, their gender, and their hair color. So person number one is 62 inches tall. So what's that? 5'2", weighs 120 pounds, is female, has brown hair. Okay, person number two, 67 inches tall, weighs 140 pounds, um, female, has black hair. We have somebody who's 72 inches tall, weighs 190 pounds, male, blonde hair, so on and so forth. I just have these fictional people, imaginary. And what we're going to do is we are going to create a scatter plot that is going to graph these individuals with dots. Okay. And so what I'm going to do in order to do this, this is the code to create the scatter plot. This code here, by the way, is used to create the table. We call this thing a data frame. Don't worry about all of this, but basically it just says the height column is going to consist of these values. The weight column consists of these values. The gender column consists of these values. The hair column, as far as hair color, consists of these values. Okay, and print just says show that data frame that we've created. Okay, um, and to create my graphic, I'm going to say, um, create a aesthetic mapping where I'm going to take the height and say put height along the x-axis, weight along the y-axis. Take gender and use that to define the colors of our points. Take the hair color and use that to define the shape of our points. And we're going to add points here. And this is the data graphic. Okay. Um, so let me kind of go back, flip between this data graphic along with our data itself. And so this first individual with a height of 62, a weight of 120 pounds, is female and has brown hair, is represented by this block right here. We could see the height along the x-axis is 62. For the weight, it's at 120. The color of the box is this reddish color corresponding to female. The shape of the point is a square corresponding to brown hair. Okay. Um, this one corresponds to a height of 65 inches and a weight of 160 pounds. That's going to be this person, 65 inches tall, 160 pounds weight. Gender, female, with the red color. Triangle means blonde hair, and that's what we have here. Okay. Here we have an individual whose height looks to be what, 66 inches tall. Okay. The weight is 135 pounds. Okay. The color is this teal color, so that corresponds to gender male, and square, so brown hair. And that's what we have here. Okay. So all we've done is we've taken this table of data and we've plotted them. Okay. We used the height along the x-axis, the weight along the y-axis, and then we've changed the shape of our dots and the color of our dots according to these other variables, hair color and gender, and things like that. And the reason why we do this, so this graphic and this table presents the same information. So why do we want to have a graphic? Okay. Well, the power of a data visualization is that it allows our brain to use its visual processing abilities to think about quantities and variables. When we look at just numeric values, our brain is not able to quickly reason about them. We can think about these, all right? It's actually really amazing that we could even get information out of this, right? The idea that we have writing, right? That we have just this kind of this funny little shape, this squiggle, and our eyes and our brain recognizes that's the number 2 or number 6. We have this other squiggle over here, and our brain recognizes that's the number 2. And by having the 6 next to the 2, we understand the 6 represents this in the tens place, so that's 60, and the 2 is in the ones place. And so this represents the quantity 62, which is amazing that we can even do that. But so we can think about this, but it's hard for us to kind of reason about these values intuitively, okay? But when we see the data represented as points, our brain is able to visually process that information and identify patterns and relationships much more quickly, okay? And so when you have a data visualization, we need to be able to map properties of the data to a graphic, and we also need to be able to go from the graphic back to the data in the brain. One thing, like, for example, we can look at this graphic here, and I could say which dot, given their height, which dot seems to indicate the person has, maybe a slightly higher weight than kind of what fits the trend here. Okay. So, like if you fit a trend line, imagine fitting a trend line to the data, and I would ask which dot, is higher above that trend line. Okay. And so we would imagine having kind of a trend line that starts in the lower left corner going into the upper right corner. And we'd say, oh, you know what? The dot that kind of seems a little bit higher would be this one right here. Okay. The one that kind of goes highest above the trend line we would say is kind of this individual right here. And which just means given this particular person's height, their weight is a little bit higher than kind of what fits the rest of the pattern, okay? And we can identify that visually just kind of by looking at that, right? We can kind of imagine fitting a trend line and we can say, oh yeah, if I imagine fitting a trend line, this dot is going to be a little bit higher. These two dots are going to be a little bit lower if we just kind of pretend to imagine a trend line. And and that is the power of the data visualization, the data graphic, versus if I said, hey, look at this and do the same thing. Imagine fitting a trend line to these values, and I want you to identify the individual whose weight is a little bit higher than what the trend line it, ex would expect, or whose individuals have weights that are a little bit lower than what the trend line would expect. And that's a lot harder to do when you only have the numbers, okay? When you have only the numbers, it's really hard to kind of identify that versus when you have it visually, our eyes and our brains are really good at picking up patterns and we can imagine fitting a straight line, we can imagine fitting dots here and there and stuff like that. And that's really what the power of the data graphic is, okay? Is that we are able to kind of use the visual processing powers of our brain, which are really good at identifying patterns and being able to um, pick out kind of unusual points like that. Okay, so yeah, so if we look at this scatter plot, if I gave you an assignment, okay, and I'm not going to do this, but if I just said, hey, using this scatter plot, I want you to recreate the table of the data, you would be able to do it, right? I could say, all right, how tall is this individual? How much does this individual weigh? This dot right here, you'd say, okay, well, this individual looks to be around 72 inches tall. Their weight is 190. Their hair color is a triangle. Their hair color is blonde. The gender is male. Okay. And you could do that. You could do that for every single dot in the scatter plot. And you could recreate the entire data table if you need to. Now it'd be a little bit tedious, but you could do it. All right. And that's really what a data graphic does, is it takes this table of data, it turns it into a graphic, but you don't lose any of the actual information. If you needed to, if I present this data graphic to you, you could create this table back again, okay? And so that's going to be important. Now, if I remove what we call a guide, like if I hid, like if I covered up this legend over here with the gender and the hair color, then you would no longer be able to do this. You would not be able to tell me um, what the gender or hair color is if we take away the guide. Or if I cover up the x-axis, if I cover up the numbers on the x-axis, or if I cover up the number on the y-axis, if I cover up those numbers, again, you would not be able to reproduce our table. So all of the different aspects, the labels on the x-axis, the labels on the y-axis, the legend here with the different shapes and the different colors, these are all important aspects of the data graphic. Okay, oh, I'm gonna forget. Let me give you your view quiz answer. Gotta look that up. So week 1, Wednesday, your first view quiz answer is the letter A. A as in apple. A as in apple is your first view quiz answer. So we have this data graphic, and we can go back and forth between the table of data and the graphic. Okay, so this is just some terminology when we're talking about data visualizations. Okay, so first we have our data. That is the information that we want to visualize. It's going to be stored in a table. Okay, we have different observations, different values, and they're stored in rows. And the different variables, the different kinds of pieces of information, those are stored in columns. And the entire table is called a data frame. The geomes are the geometric objects that we use to represent the data. In our case, the geomes, the geometric objects, are these little dots. Each dot represents an observation in our data table. So we have these, squares and these triangles and these circles, these, I guess we call them points here. Okay. You can have other data geometric objects such as bars or lines. There's all sorts of things. With the scatter plot, we've got the points. We have aesthetic attributes. The aesthetic attributes are things like the position of the point, the X position, where it is horizontally or where it is vertically. And that's going to tell us information about the data. It's things like the shape of that point, the color of the point. And there's different other kind of aesthetic attributes that we can do as well. The mapping is how we connect the data values in that table to the aesthetic attributes. So we said, hey, you know what? Take the height and use the height to determine where it is in the horizontal direction. Take the weight and map it to the vertical direction. Okay. Take the gender and associate that with the color of the point. Take the hair color and associate that with the shape of the point. Those are the mappings that we have. The scales determine how the values are transformed to aesthetic values, okay? And then the guides are the visual aids here that allow us to go from the visuals back to the data space, okay? It helps the viewers interpret the mapping between the aesthetics and the data values. So when we look at our scatter plot, our geometric objects are the points, okay? And then we have things like height gets mapped to the X direction. The variable weight gets mapped to the Y direction. The variable gender gets mapped to the color of the point. The variable hair color gets mapped to the shape of the point, okay? Um, The scales were automatically determined by ggplot, and that just says, hey, you know what? It looked at the data and it says, you know what? The smallest X value for height is around 62 and the largest is 72. So it said, all right, we're going to put 62 in the left-hand side and 72 on the right-hand side. And it puts a little kind of extra padding there. So the right-hand side is like 72.5 and the left side is, I don't know, maybe 61.5. It also says, okay, as far as height goes, the smallest value I see is 120 and the largest value I see is 190. So it puts 120 on the bottom and 190 near the top. And it kind of automatically scales the picture so that our data fits it, right? If you didn't know and you decided you're going to start in the corner 0, 0, the lower left-hand corner would be 0, 0. Your picture would look, quite a bit different, okay? Um, the guides being the legends and the tick marks on the X and the Y axis, those are also automatically created by ggplot. Okay. Um, so here, this is what we have. We started off by mapping height to X and weight to Y and gender to color and hair to the shape. I could change these around. Okay. So this is kind of our original scatter plot that we have. One thing I could do is I could change and I could say, you know what, take the hair color and make that the color of the point, and take the gender of the individuals and map that to the shape. So what is going to happen here? All right. Well, we have three hair colors. We have black hair, blonde hair, and brown hair in our data set, and they appear here. Okay. We have brown hair gets represented by these blue color, and these two individuals have brown hair. Black gets represented with the red color, and they're these two individuals, and so on and so forth. And then as far as the shape of the point, we have circles representing female, and we have triangles representing male. Okay, at least with these six individuals. So this scatter plot, even though it looks a little bit different, contains the exact same information as this scatter plot, right? Right. If I gave you this scatter plot and I said recreate the data table, you could recreate the data table. You could say, all right, here's a person 62 inches tall, 120 pounds, female with brown hair. This scatter plot is same exact thing. 62 inches tall, 120 pounds, and we say, okay, circle corresponds to female. Blue corresponds to brown hair. Okay, so it's the exact same information, even though it looks a little bit different. Okay, it's just here the individual's gender determined the color of the point, and the hair color, individual's hair color determined the shape of the point. Okay, here the gender determines the shape of the point, and the hair color determined the color of the point. So same information, we've just changed the aesthetic mapping. Okay, so one thing to note is our eyes are generally drawn to the color first, and then we'll notice the shape secondary. So if you have kind of these categorical variables, generally use color to represent the more important categorical variable and use the shape for kind of the less important categorical variable. Okay, does that kind of make sense? That these two plots carry the exact same information, just we've changed how we've mapped the variables to the aesthetic attributes. Okay, let me go ahead and give you your second view quiz answer, which is the letter B, B as in bear. Okay, B as in bear. Okay, what about some unusual mappings? What if I tried to map a categorical variable like the hair color to, say, the y-axis? Okay, and what would happen if I took the numeric variable like weight and I put it on and I mapped it to the color aesthetic? Okay, and so I would do this something like this. So I'm going to still have height on the x-axis, but now the hair color, remember I have blonde hair, brown hair, and black hair. Okay, that's going to go along the y-axis. And the weight, which went from like 120 pounds to 190 pounds in our data set, is going to get mapped to the color. Is this even possible? Okay, we'll go ahead and leave gender with the shape. What would happen here? Okay, well, ggplot tries to do its best. And so this actually, as different as it looks from here, also contains the exact same information. This plot contains the exact same information as this plot, even though they look quite a bit different. So here, this dot represents an individual whose height is 62 inches, whose hair color is brown. Okay, so as far as the Y position, we have three positions where dots can be. It could be kind of along this line down here, and this will represent individuals with black hair. This, if it's along in this Y position in the middle, it represents individuals with blonde hair. If it's at the top, it represents individuals with brown hair. Okay, so this person has brown hair, is 62 inches tall, and their gender is female. And as far as weight goes, now this is a little bit tougher, but we're trying to represent weight using different colors. And because weight is numeric, we're going to have a gradient. So if the person is 120 pounds, they're going to get represented with kind of a dark blue. And if they are heavier, like 190 pounds, they're going to be represented with a bright blue. So this person is lower. Now, it does make it difficult, okay? When I look at these two individuals, it's tough to tell who has greater or lower weight, right? These two have very similar colorings. These two dots also have very similar colorings regarding weight. So it's hard to know who is heavier among these. But this is the brightest color, so this would probably be the individual who's 190 pounds, 72 inches tall, male, and their hair color is blonde. Okay, so if you had to recreate the data table, you could. Perhaps your numbers for weight will not be super accurate, but again, the same information in this graphic is contained in this graphic and this graphic as well. Okay, it's just a little bit tougher to distinguish the weight colors just because our eyes aren't so good at distinguishing, slightly different shades of a color. Okay, some people can really identify, different shades of color, but depending on, I guess, the cones and the rods in our eye, it might be difficult to know which between this color and this color, which one's brighter or darker. So that might be tough. Okay, but but basically, our computer system, ggplot, is tries to do the best it can with the instructions we give it. We say things like, yeah, take the hair color and put that on the y-axis, or take the weight and put that on a continuous color scale going from kind of dark to bright. And even though it feels like representing a number with a y coordinate feels different than representing a number with the color, at an abstract level, they're the same thing. We are taking a data property, a value, and we are turning it into a visual aspect, whether it's the color, the visual aspect of the color, or the visual aspect of where it's positioned vertically or horizontally, or whatever it might be. We are taking a data value and turning it into a visual property. So some of the aesthetics that we can use are going to be determined by what variable type we have. So certain aesthetics can really only work with categorical variables. For example, the shape of a point, whether we're going to use a triangle or a circle or a square, that's only going to work if you have a categorical variable. It would be difficult to take some kind of numeric quantity like a person's weight and I would just say it's not possible and try to represent different weights with the shape of a point. Okay. Um, some other aesthetics, like the X position or the Y position, can work with categorical variables or numeric ones. So, we saw the Y position could be used for the weight. Lower values would be lower weight, higher value, if it's high vertically, it would be higher weight. But also we could say, hey, we could say this position corresponds to this category. This position corresponds to black hair. This position corresponds to blonde hair. This position corresponds to brown hair, or something like that. Okay. And if you have something like a bar graph, the x-axis is usually used for categorical variables. For something like a scatter plot, your x and your y-axis will usually be numeric variables. But yeah, we'll take in future lectures, we'll have um, different examples, and you'll see, how we can produce some of these things. Okay. All right. So let me give you some kind of very basics for kind of starting and creating a data graphic from scratch. And so I'm going to show you this again. All of this code, eventually you will learn, but in the beginning, it's going to feel overwhelming. It's going to feel like a lot, and that's okay. Um, but here's just to kind of get you exposed. So here, this code is just to create a data frame. And again, I have everything kind of wrapped in this parentheses that says this is, we're going to have a data frame, and I've got these different columns. A very common way to get data into R is to just import a data file. So you have these data files that come in like CSVs, comma separated value files, basically little Excel worksheet type things, and you can import those into R. But you can also manually create them. And so here I've just manually created this data set. Again, 6 fictional people with different heights, weights, genders, and hair colors. And the very first thing I might try to do is I can create um, a ggplot graphic. And when you do this, you say, I want to make a graphic using the data frame. The data frame I've stored it as df. Okay. This little arrow means take the result of data frame and put it into, uh, give it the name df. All right. And so I'm going to say, hey, I want to use that data frame df. And I'm going to do an aesthetic mapping. That's the AES function. I'm going to say map the height to X and the weight to Y. Now we don't have any geometric objects. So it just kind of creates an empty graph here. We just have an empty graph, but it says, hey, I've got height on the X-axis, weight on the Y-axis. That's all we have right now. And so that previous command here with ggplot um, creates a ggplot object, basically a graph using the data frame. It also specifies our aesthetic mappings. Height goes to the X, weight goes to the Y. Um, but we don't have any geometric objects. So that's something we need to tell it. And so we're going to say, hey, you know what? Add point geometric objects. And when we do that, we get a scatter plot. So here I've got the same line before, and then I say add geometric points. Okay, geometric objects points. And we get these 6 dots. These are the 6 dots in our data. And again, we can see, all right, now we have an individual, height of 62, weight of 120. Here we have an individual, height of 65, weight 160, height of 66, weight of 135, and so on and so forth. We've got these different individuals here. And what happened to hair color? What happened to gender? Well, we never mapped those to any of our aesthetic attributes. We don't see those variables listed anywhere here, so that information is not contained in our graphic. Okay. As we kind of mess around and work on our graphic, there are things where we can, rather than having to rewrite certain things over and over again, we can just say, hey, you know what? Start off with this basic thing, the ggplot where we've got height to X and weight to Y and so on and so forth. We can call that part right there, we can call it object, and I've just given an arbitrary name, P, like P for picture or something like that. Okay. And so we can store this and we can refer to this later, and I can just say, hey, do P plus geopoint. And that would be exactly equivalent to this because P, that object P now represents ggplot df, AES, X equals height, Y equals weight. Okay, so we can do this. Ggplot df is AES is X equals height and Y equals weight. That's going to be object P, and I can just say, hey, take P and then add geopoints. This is going to be exactly that. And then I can say, well, you know what? I want to now also take the gender variable and map that to the color of the point. And we can do that, and we can say we're doing another aesthetic mapping here. And so I have AES, and we're going to say color equals gender. And when we do that, that now gets included here, okay? So here I have a little dot here, 62 inches tall, 120 pounds for weight. And we could see this color, the dot is the little red color. And so that corresponds to female. And we also have, these points which are blue, which correspond to male, and so on and so forth. And that's what we have for this particular data set. Okay. Now, there are other things, okay? There are things that we can call just settings, okay? When you do a setting, okay, that is going to just set an aesthetic attribute like the color or the size to a certain value. But these are not mapped to aspects of the data. So I could just say, hey, I want the color to be blue. I want the size of my point to be 10, okay? And here, notice I don't have it inside AES, okay? I just have color, geopoint, color equals blue, size equals 10. And what that's going to do is it's going to make all of the points blue in color, all of the points size 10. And this is what we have. Okay. This this plot, okay, has some of the same information as this plot. The height and the weight dots or positions are the same, except over here I have gender, the variable gender mapped to color. And so we have different colors here, red for female and blue for male. Whereas over here, the color doesn't tell me anything about the data. All of the points are blue, okay? It is not, seeing that a point is blue doesn't tell me if the individual is male or female or what hair color they have. It's just a setting, okay? This is an aesthetic setting. The size of the point also doesn't give me any information. All of the points are the same size, so there's no information being carried there. Okay. So that's the difference between a setting where you're just saying everything is going to be blue in color or everything's going to be size 10. Whereas over here, we're going to say the color of the point carries information. The color of the point carries information about the gender. And that's an aesthetic mapping. So when you want the aesthetic attribute to carry information about the data, you use an aesthetic mapping. If you just want the aesthetic attribute to have a certain setting so that, you like it, okay? For example, I think it makes sense to have bigger points with larger size that you can just do that. But again, here, this is not carrying any information about the data. Okay, so that's the difference between a setting and an aesthetic mapping. There are other things. You can change say, the scale. And so ggplot automatically determined the scale based on the range of the values. But here you could say, you know what, I want the left-hand side of my graph to start at 60 and the right-hand side to end at 100. I could change my scale on the x-axis, okay, to be something like this. And now the left-hand side will be 60 and the right-hand side will be 100. And it's kind of, this information is here, but it's just kind of, now it looks a little bit more squished, okay? Same information. If I said, hey, try to tell me, what is this person's height? You might be able to figure out it's 72. This individual is 65 inches. This individual is, 68 inches or something like that. So that information is there. It's just, squished in a little bit. Okay. And so you can kind of change these things. Now, recording in progress. Nope. I don't know what happened there, but do we expect you to memorize all of these things? No. You would go to Google and you'd say, how do I change the limits on the x-axis in ggplot or something like that? And it will say, oh yeah, you can do this using scale x continuous. So there are a whole bunch of these different commands that are out there, and you'll use the internet, you'll use Google, you'll search for these things, and how do I change some of these different aspects. But these are all parts of the graphic that you can kind of customize to fit the needs that you have. um, how many view quiz answers have I given you? One, two? I don't remember. Two. I've given you two so far. Okay. Let me go ahead and give you your third one. The third one is the letter E. E as in elephant. E as in elephant. Okay. All right. So let's say I'm mapping gender to the color of the point. So the color of the point is going to carry information about the gender. And you can choose to change the how those colors or those variables are represented with colors. Now, the default color choice, I think, this is kind of the default color choice. R or ggplot picks kind of this reddish salmon color and this bluish teal color. Now, if you wanted to kind of go with like, I don't know, from the hospital, they generally use pink and sky blue or something for these things. You could do that as well. So, you could say, okay, I want to have female represented with pink and male represented with blue, as if, this is like a gender reveal or something like that. Um, you could do that, right? And this is again changing the way the colors, the aesthetics get mapped to different colors. So you can change that. Okay. Let's say here I wanted to change hair color, right? So in one of my earlier plots, we had, way back here, we had the hair color. We had black hair, blonde hair, and brown hair. But the default is, picking our picks, red, green, and blue, which, for something like hair color, and you say you got black hair and blonde hair and brown hair, maybe you want to actually show something that kind of is representative of those hair colors. And so, kind of flipping around to here, I could say, hey, you know what? I want black hair to be black, and I want blonde hair to be kind of this yellowish golden color, and I want brown hair to be this kind of brown color. And you can search the internet for like named colors. You can put in hex codes for colors and things like that. And so this brown color, this is known as, say, chocolate 4. But again, you could search the internet and you can say R named colors, and you have, what is this? Okay. You have a bunch of kind of different colors out there that you can use to kind of plot some of these things. So these are just different aspects that you can kind of customize as you need. Okay. Um, there are kind of different themes you can do. I think the default is theme gray, but you can kind of change it to like black and white and stuff like that. Let me see. We can do like ggplot themes. Um, and there's different aspects. So the default is kind of having this gray background, but you can have like black and white and line draw and dark color, just kind of different things. If you don't like the lines, you can have classic, no lines at all, and stuff like that. So there's different themes you can have to um, customize the way some of your plots look. Okay. And again, lots of kind of code here, but this is how we're going to be interacting with the computer to kind of get it to display things exactly how we want. And again, just like anything else with practice and exposure, you will get better at it. All right. And I know this is our first lecture. I'm not expecting anybody to be super proficient right now, but just so you can start, this is just to expose you to some of the code that we have. And as we work through and I show you more examples and I explain them, eventually you'll pick all of this up. You'll have exercises in your homework, and that's all coming there. Okay, so we'll go ahead and wrap things up here. And so we'll end here for now. And then yeah, we'll see you guys on Friday. I will have office hours later today at 11:15 online. So if you have questions, feel free to stop by. Otherwise, have a great rest of your day, and we'll see you back online on Friday.
Thank you.
Thank you.